Hello students and welcome back to the video lecture series of software engineering. Today's topic is software configuration management. I am your instructor Ms. Shruti Raval. So let us start with today's outline. So in today's lecture we are going to study the basics of SCM, that is software configuration management, and the next thing that we are going to study is SCM process. We will see the whole SCM process, how it is actually done in a software industry, right? So let us start with the basics of SCM, that is software configuration management. Now what do you mean by software configuration management? Software configuration management, shortly known as software change management, it is basically a set of activities that have been developed in software industry to manage changes throughout the software life cycle. Okay, so we know that change is the only constant thing and changes in software are inevitable. So there will be occurrences of change every now and then, but we have to maintain the changes and we have to maintain the consistency of our software with respect to those changes, and all the activities that we perform, starting from whether we should actually accommodate that change or not, after applying the change what is the actual version of our software or the configuration item that we have changed, everything combinedly is known as software configuration management. So basically, why is change required? Because there may be changes in requirement. We know that clients are having ever changing requirements, right? So there is a 100% possibility that client will change their requirements after delivering the software or in between. So there will be a requirement for change in our software. The next is change in team or organization. So it is a possibility that we have a predefined structure of our organization or our team which is involved in our software, but that predefined structure is also about to change. Then changes may be introduced to your software. The next is if there is a change in government policy. This we have discussed earlier when we were discussing software maintenance, right? That why is modification necessary in software. So we have discussed there also that if there is a government policy and if there is some sort of change in that policy, then we may have to update our software according to the change of government policy if it is referring to that policy. The next change is basically change in the project schedule, right? So if we have a predefined schedule that we have defined for our software, but if we are not following the schedule or if there is a drastic change in our schedule, then there is a possibility that we may have to deviate to from our process model or from the functionalities that we are accommodating. So these changes may affect the software to change, right? It may affect the documentation to change. So we have to actually accommodate those changes in the documentation as well as the software itself due to the change in schedule. So due to this all changes, there is a possibility that there is changes in the code that you are doing. There is changes in the whole project plan that you are doing, because we know that if the schedule is changed, the overall project planning is changed. Other documents, for example, if you are deciding to not include some of the functionalities that you are previously going to include due to the tight schedule, then the document that you have prepared, the design document that you have prepared or the architecture that you have prepared, that also will be changed, right? The next is the test cases. Obviously, if your source code is changing or the documents itself is changing, the test planning or the SQA planning that you have done, that is also bound to change. And the last is data changes. So it is a possibility that we may update the data model or the database that we are using, right? So if there is a change in any of these particular scenario, then database or data model may also be changed, right? So these are the things that may affect these all things, and if any of the things, that is code, project plan, document or your data is changed, we have to apply software configuration management so that there is a consistency in change, right? Now let us study in detail what is the SCM process, right? So for studying SCM process, the first thing that we will need to study is SCI, that is software configuration item. We will study in detail what do you mean by software configuration item, but you need to understand that SCI is the first thing that you need to identify for performing SCM process. So that is, yes, you have to identify. So identification is basically the identification of all software configurable items. So that is the first phase of SCM. The next phase is baseline. Now baseline is something that is, you can say that when your all software configuration item are frozen, it means this is a version that we have decided that is a quality version which has been reviewed thoroughly, which has been tested, and now if you want to apply any change in this baseline version, you have to follow a formal procedure. It means you have to issue a change request and then only you can apply changes in this baseline, right? The next is change control. So you have a whole change control mechanism for applying changes in your baseline version of your software. So we will study what is the change control mechanism or process. After change control comes your version control, right? So because you cannot apply all the changes in one version of your software, right? So if there are major changes in your software, you have to deploy different versions of your software and you have to take a note that what changes were done in which version. So that sort of handling is coming under version control. And the last is configuration and audit review. It means all the activities that we have performed in software configuration management, they have to be audited or reviewed properly, and the status of that audit has to be reported to the higher management, right? So that is the last process of software configuration management phase. So in total, how many phases? The first is identification, the next is change control, the third is version control, and the fourth is configuration and audit review. So let us see the first thing, that is configuration item. Now what do you mean by configuration item? So basically you have a system that is a software system and you are breaking the whole system into number of known and manageable parts, and these parts individually are known as software configuration items. And why are we breaking this system into configuration items? Because these are the items that are affected by the change that we will apply to our software. So what are the configuration items? You can say that the design document that you produce for your system is a configuration item. Any function that you write is a configuration item. Any requirement document is a configuration item. The whole test suite or a particular test case that you write is a configuration item. So you can get an idea that when you apply the change on your software, these are the items that will get affected, right? Now the first thing that we have to do for the SCM process is you have to identify these configuration items and you have to uniquely give them identification, right? So identifying the various revisions as a part as it evolves throughout the development cycle. So we know that the software is an ever evolving cycle, or it is known as a development cycle, starting from the requirement to maintenance, and in changes also there will be different phases, right? Now if we are applying a change and if that change is being affected for a particular configuration item, you have to properly manage that which configuration item is affected by the change, what was the revision or what was the version number of your software. So that should be the combination. So configuration item should be uniquely identified and the version of the software in which this configuration item was changed, that should be mapped, so that we can get an idea that during the course of this whole software development, all the versions of the software, for example, if you have 3 versions of the software, right? If you have version 1, you have version 1.2 and version 1.3. So there are different 3 versions of your software that are deployed, right? Now in these 3 versions, there will be configuration items that will be uniquely identified and there will be changes in all the versions. I should be able to identify that which configuration item was changed in which version, who changed it, right? So that is the main thing that we have to first identify uniquely this configuration item, and revision of this configuration item should be managed. So for this we have to keep a detailed and accurate record of all the configuration items that we have identified in each of the version of our software, in a register, or you can say a database that is known as CIR, that is configuration item register. So in configuration item register, you will have the version of your software, you will uniquely have the configuration item and what changes were applied to that configuration item, right? Now let us see one of the example of configuration item, that is software configuration item. So here is an example. You can see this is the configuration. Now what is this whole thing? Basically we have a software which is deployed in a railway. So this is basically an environment maintenance software in which the air conditioning and the smoke detectors are basically detected, right? So this is a software regarding that environment maintenance. So here you can see that you have a central station. So there is one central station which has all the monitoring, and all the railways which are having this software are connected to this central station, right? So in central station you can see we have divided the configuration items into three parts. The first one is LCP, the next one is RTU, and the third one is IBP. Now what do you mean by LCP? LCP is local control panel. So this is the control panel which is showing the conditions of your air conditions, the smoke detectors, etc. RTU is basically your remote terminal unit which is doing the all logic and processing. And the last is your IBP. So IBP is basically integrated backup panel. So if your software, automated software detection is failing, so IBP will take over the manual handling, right? So that is a backup panel. So we have divided these into major categories. Now in LCP, RTU and IBP also you can see that there are some items which have been recognized. So LCP, there is software, display and database. In RTU there are firmware, configuration and logic, and in IBP there is only logic, right? So these all are the items that we can say are configuration items. So you are getting an idea that if there is an embedded software, not only the software things or the documents are regarded as configuration items, but also the hardware can be recognized as a configuration item. And you can see over here, this is a table. The first column is configuration item. So if you are taking one configuration item from LCP, that is local control panel. So if you are taking the software from local control panel, the unique identification I am giving is LCP, that what is the main you can say panel from which I am taking this configuration item, so that is LCP. And what is the actual item? That is software. So LCP software, that is uniquely identifying the software of local control panel, right? So that is a unique name for this configuration item. Again, with the name I will have a unique identification, that is an ID number, which is a unique number which is attached to every configuration item. Also I have a revision number. So this is the version number which has been attached to this particular configuration item, right? So whenever I change anything in any of this configuration item, I will have to maintain every changes in this configuration item register, right? So this was a small example of software configuration item. Now let us further see in our process. In SCM, if you remember, the first process that was taking place was identification of SCI, that is software configuration item. The second process is baseline. Now what do you mean by baseline? Baseline I have briefly told you. Baseline is a formally accepted version of a software configuration item, and it is designated and fixed at a specific time while conducting the SCM process. What does this mean? It means that when we have performed a particular software process, we have designated and frozen the state of our software configuration item. So if you are following a software process and if there is a particular state of configuration item which is reviewed, for example, if you are developing a database design document, right? So we know that after database design document we will have a formal technical review of that document, right? So if the quality analyst or the formal technical reviewer team is telling that okay, this is a perfect database for our software and this is a baseline configuration item, right? So it means now for our software version that database design is fixed. Now when I commit this database design as a baseline design, after these particular thing or after this baseline, if I want to apply any change in this configuration item, I have to apply a proper change control procedure, that is known as a formal change control procedure. Right, you cannot directly change the baseline configuration item. So all the configuration items are decided baseline when you deploy a particular software. So for example, in our previous example, let's say I have a 3 version of my software, 1.1 and 1.2. So when after deploying my software as version 1, all the configuration items in my version 1 are baseline. So now if I want to change any of the configurable item, I have to apply a formal procedure in which I have to request for the change in that baseline, and then only I can accommodate a change if that change request is approved. Right, so that is a baseline. So change, what is change? Change is a movement from this baseline state to a next state. Right, so you have a particular state of database design. If you want to alter that design, and if that particular state is a baseline state, you will have to follow a formal procedure of change control. Right. The next process is, yes, change control. So we told that if my version is deployed, if it is known as baseline, baseline is the version of your software which has been accepted by the testers and the formal technical review team and told that this version is ready to deploy. Now if I want some change in that baseline software, then I will have to apply change control mechanism. So the first thing is need for change is recognized. Even though I have a baseline, I have a version which is fully developed, it is a possibility that there is some sort of need for change, and we have already discussed why there may be a change need, right? So the first thing is there is a need for change. The next is this change request may be from the user, right? The user is requesting some sort of functionality change, or it is requesting some sort of new functionality to be added, right? Or there may be some error that user has recognized and you may have not recognized. So there may be a change request from user. After the change request from user, the developer himself evaluates that whether there is a genuine error or whether the request from user is genuine and feasible or not. After evaluation of developer, the change report is generated, that what is the actual change which is requested by the user. The whole report is generated by the developer. That report is given to the change control authority. Now this change control authority is basically either the technical lead or the project manager or the product owner of this change control mechanism, right? Now this control authority will have two options. After evaluating the whole change report, he may either decide that this change request is not genuine or it is not feasible. We cannot change the configuration item which is requested by the user. So he may request, he may deny the request. And if the change request is denied, user is informed, right? So through a proper channel, the user is informed that your change request is not accepted, and you have to give the reason why your change is denied. Now if the change request is not denied, it means the next option is your change request is accepted. So request is queued for action, because it is a possibility that currently there are some major methods or functionalities which are being implemented, and this change request is not in priority. So we are keeping this change request in queue, right? Now after the change request is in queue, what will happen? We will assign individual configuration, we will assign individuals to configuration objects. It means that there will be some configuration objects that we have already identified which are to be changed, right? So there may be some configuration items that may be changed through this change request. We are assigning these configuration items to the developers who will change that particular items, right? The next thing after that is checkout. Checkout, it means there is a version that has already been baselined. Okay, so we have committed that version in a particular software tool, and because everybody is working simultaneously on the same software, right? So you cannot randomly pick the files and do changes. There should be a mechanism in which one person, if he wants to collaboratively work on a file, he has to check out that file, that is the configuration object or item on which the change should be applied. He has to check out it so that all others get an idea that he is working on this particular object. So when he is checking out an object or configuration item, then he can actually make the change. Okay, so once he checks out the item, he will make the change. After applying the appropriate change, what will be done? Yes, the review of change will be done. So himself, he will review the change. Change control authority is deciding whether this change is perfect and according to the standard or not, whether there is an error in the change or not. Due to this change, are any other configuration items affected or not, right? So these are the things that will be reviewed by the change control authority. After reviewing everything, the file or the configuration object that the developer had checked out, he will again check in that configuration item that has been changed. So that is the final copy that has been checked in, and you will establish a baseline for testing, because this is the change that has been made by the developer and the review is done, but still the testing of that change is pending. So now the next thing is actually the testing activities for that particular change is commenced, right? Because you know that that change should also be tested, and you should also check whether any other configuration items are affected by this change or not. So regression testing is also performed, right? The next is you are promoting these changes for inclusion in next release. Now there will be something called, you can say that if there is a change request which is not feasible, then you may apply some of the request of the user, and some of the request you will tell that it will be applied in the next revision or next version of my software that will be released. So that things are decided by the testing. The next is rebuilding of the version, because we have committed or we have checked in our configuration items, but still we have not rebuilt the whole software. So because this version was baseline in which we have applied the change, now we need to rebuild the version. So for example, currently we were in the version 1.1, and if there is a change which is very trivial or which is very basic, we can rebuild our new version 1.1.1. So the new software that will be deployed will be of version 1.1.1. Right. So you will again review the changes of all configuration items after rebuilding the version also, and you will include the change in new version. So whatever version now you have trying to deploy, that is 1.1.1 in our example, that all the changes you are including in the new version that will be deployed, right? So finally you will distribute the new version, because all the changes that has been done have been accommodated in the new version, that is the latest version, and now this is again a baseline version. It means all the changes are finalized, all the changes are reviewed, all the configuration items are reviewed, are checked for quality, and now we are distributing this version to the user, that is 1.1.1 for our example. This is also a baseline version. Now again, if you want any change in this baseline version, you will have to follow this change control mechanism again. Right. After change control, you have one topic to learn, that is version control. What do you mean by version control? When your item is baseline, it becomes frozen, right? Now the term frozen means that the item can only be changed by creating a new version, that we have already seen. So it is very necessary that you apply version control. What do you mean by version control? Version control combines all the procedures and tools to manage different versions of all the configuration items that are created during the software process. So we have seen in the previous slide that we were changing some of the configuration items, and we have changed that configuration item in a particular version, right? So we need to get an idea that what were the configuration items, in what version we have changed, who have changed, and when have changed. So this all question answers is basically version control, right? So version control system is integrated with the following capabilities. The first is repository. Now what is this repository? This repository basically contains all the related software configuration items of your particular software version. The next is VMC, that is version management capability. It means in repository we have all the related configuration items for that particular version. in version management, we have a list that this configuration item is uniquely identified with this number and it was changed in this particular version, right? So that is a version management capability which a version control tool should have. The next is make facility. Make facility, it means if there is a baseline and if I want to commit changes in a particular configuration item, version control tool should be able to do that. It means I should be able to check out the configuration item, make changes in the configuration item and then check in, right? So that collaboratively I can work on the single software and the version is still maintained or the consistency is still maintained, right? The next is BTC, that is bug tracking capability. Now it is also possible that when you are making changes in configuration items, there will be bugs that are introduced, right? So version control should also have a capability in which it showcases that in which version what configuration items had which bug, right? So that capability also should be there in your version control, right? So also a version control should maintain a change set, okay, because configuration management is all about changes. So there should be a change set that is maintained in version control tool which serves as a collection of all the changes you have made to a baseline configuration. So for example, our version currently is 1.1.1 and this is my baseline version of the software. Now if I am performing any changes in 1.1.1, I will have to follow a proper formal change control mechanism, right? All the software configuration items that I am changing in 1.1.1, that changes should be maintained in my version control. Similarly, if I have 5 versions of this particular software, what changes were made in each of the versions should be maintained. That is known as a change set. Why it is necessary? Because it is used to create a specific version of a software, right? It captures all the changes of configuration along with the reason that why was the change needed, along with the details that who made the change and the details when the change was made, right? Let us see what are the few version control system. LJIET is a GitHub, you may have heard the name. That is a very good version control tool that you can use. It is an online tool. Visual Studio, that is also one of the tool. The next is Tortoise SVN and the last is Perforce, right? So these all are the version control tools that you can use if you are simultaneously working on the same software, if you want to maintain the versions of all the configuration items, if you want to make the changes while maintaining versions of each of them, then you can use these tools, right? And the next topic or the next phase in process is configuration audit. Now configuration audit is basically ensuring that all the changes that you have made to your baseline version, they are properly made and they are the quality changes, right? So in configuration audit, there are 2 things that are basically performed. The first one is formal technical review. We know what do you mean by formal technical review. So when the changes are made, when you commit the changes, then formal technical review is applied in which all the documentation regarding that change is checked by the FTR team and they check that whether your change is according to the quality standards or not, right? And the next is configuration audit. Configuration audit is checking all the things that FTR has not actually checked, right? So configuration audit is checking that whether the change is done in the correct version or not, because it is a possibility that if there are multiple versions of the software, each consists of similar configuration items, it is a possibility that I check out something from different version, I make a change in different version and commit in different version, right? So is there a mismatch in this versioning? That is what configuration audit is checking. Whether the change is affecting some of the other configuration items, that is the configuration audit checking. Whether the change consists of any error or not, that is the configuration audit checking, right? So all the changes that you have made, are they consistent with respect to version or not? That is what configuration audit is ensuring. So after applying formal technical review, that is the standard that you have followed, and configuration audit, it means checking all the changes whether you have applied correctly in the correct version or not. The last phase of SCM process is status reporting. Now it is also known as status accounting. This is also basically an SCM task which answers this following question, that what happened. It means what was the change that was happening, who did it, who is the person who is responsible for making the change, when did it happen, the exact date on which the change was occurred, and what else will be affected. It means are there any other configuration items that are affected for due to the change in one item. So these all things are answered and they are reported. To whom they are reported? To the higher management they are reported, right? So basically status reporting entry is made. Now this can be an online entry, that is you may have an online software or website on which you are doing this entry. This may be a hard copy entry, but you have to report this. So basically you have SCI is assigned a new or updated identification, right? So because I know that now the software configuration item is changing from one version to another version, so the identification of that software configuration item in the new version should be different, right? So that version number should be attached to this configuration item, so that should be updated in your configuration item register. Also this all changes which was approved by the CCB, that is change committee board, that all document should be there which should be reported, and all the results, that is when the audit was performed, when the formal technical review was performed, the all overall report that was generated by the auditing team, that report should also be given to the higher authority or project manager, and it should be kept in the database, right? That database may be an online database, so that we get an idea that we have a proper documentation of every change related to every version, right? So this was all about SCM process and how we maintain changes in a software even after it is baseline. So this was all about today's lecture. Thank you.